So good morning, and today we are going to start with Git. Okay. So Git, actually we have two things here: Git and then GitHub as well. Git and GitHub. Okay. Okay. So what's the difference between these two? Firstly, so what is a Git? A GitHub. See, both are repositories. Okay. So both are repositories. They are repositories, or else you can call them the version control tools. The version control tools. Okay. Repositories are version control tools. And so this is same as SVN, like we have gone through the SVN, right? Subversion, SVN. Okay. So Git, actually we have three repositories, three kinds of repositories, which is SVN, Git, and then GitHub. So we have these three different repositories. But what is Git and what is GitHub? See, Git is again this Git. Okay. Okay. So Git is, it is again just same, just like SVN. That means it is, we call it repository. It's a local repository. Local repositories are on premises. That means if you want to maintain the repositories, if you want to maintain the repositories within your premises, okay, if you want to maintain the repositories within premises, we go for either Git or SVN. Okay, clear? But I don't want to maintain any repositories within local, okay, or on premises. That means within organization, I don't want to maintain any repositories. I want to maintain a repository which is on cloud. Then you go for GitHub. It's a cloud repository. GitHub is a cloud repository, whereas SV and Git are on premises within organization. Okay. So first we'll start with Git, and then after that we'll start with GitHub. So first we'll start with Git, and then we'll finish off Git. Then GitHub we'll start with. Okay. See, so I'm going to cover both the repositories, which is Git local repository as well as GitHub cloud repository. Okay. Right. And here, uh, GitHub. Okay. Right. GitHub and then Git. So all the commands are same. The commands, they're same commands. So if you use Git or if you use GitHub, both are we go for same commands. Everything will be the same. Okay. So commands purpose, there won't be any difference. But only thing is the maintenance, like how you maintain the repository is different. Okay. And moreover, what is the advantage of going for cloud repository? So what is advantage here? Why? Why cloud? Anyone? Why we go for cloud firstly? The first thing is we should not bother about any hardware, any infrastructure, or any installation, right? So without any installations, without any headaches of any infrastructure, so we can go for, we can create a cloud repository. See, creating a cloud repository is very easy. You can create it within a minute. You can create a GitHub repository within a minute. But if you go for Git or SVN, so what you need to do, you need to first install it, then start using it. So for installation purpose itself, it's going to take some time, right? At least 15-20 minutes if you do it for the first time. Okay, right? So in order to avoid such kind of infrastructure headaches and installations, configurations, so we go for cloud repositories. Okay, so which is GitHub. Clear? Right. Now, but before that, we'll try to understand the differences between Git and SVN. Git and SVN. We try to understand the differences between Git and SVN. Okay, right. See, firstly, Git and SVN both are on-premises repositories. That's why both are on-premises. We maintain both on-premises. Okay, that's the first one. And the second is SVN. It works on client-server architecture. Client works on client-server architecture. Okay, but whereas Git works on distributed architecture. Distributed architecture. Okay. So what is distributed architecture? Okay. Now we'll look into this. Okay, this is very important. We'll look into this. Now here, just say this is. I have a SVN repository. This SVN repository. Okay, and there are some clients using this repositories. Here we have some clients. That means the developers. Okay, so these are the developers or clients. They use the repositories. Okay, so we know the steps. First, they clone it. Okay, they clone it, and then they start using this. Okay, and also here try to understand the differences as well. So what's not clone, right? Check out. Sorry. Okay, in SVN, now here we are talking about SVN. Okay, just try to understand the difference here. Here I'm talking about SVN repositories. Okay, so I'm trying to compare the differences between SVN and Git. Okay, so what is the first step we do in SVN? We need to check out, right? We need to check out. Okay, and once we do the checkout, here we do some edits on the local repositories. Edit. Okay, and after that, what do we do next? What the developers do? Yeah, yeah, they have done the changes. Okay, they have done the changes. Then after that, update, commit. Okay, they need to commit it. Of course, they need to update as well. But here, further they need to commit. Okay, so check out, commit. Okay, just try to understand these differences. Now, let's talk about Git now. Okay, here, just say I have a Git repository. Okay, this is the Git repository. That is Git repository. Okay, as we know, developers use the repository. Okay, developers use the repository. We know this. Now, so what is the step we call here? See, they need to have the central repository on their developers local system, right? Okay, so they need to have it on their local system. Developers. So what do we call this operation? We call it clone. Okay, we call this operation clone. Whereas in SVN we call it checkout. Okay, right. And once they clone that, they'll be having they have the repositories local, and then they start edit. They do the changes. Okay, and after that, what's next we have here is they need to commit it. Okay, but try to understand difference here. Here we don't call commit, we call it push. Okay, we call it push. It is push operation. So what happens when we push it? The changes will be applied onto the central repository. Okay, right. But remember this, before that, okay, before they push it, what they do is they need to commit it. Before they push it, they need to commit. We have one more operation here. Try to understand the difference here. We have one more operation. Before we push it, we need to commit the changes. See, we are pushing it, right? So we are pushing it, changes will be applied onto the central repository. Then what is commit again? So the commit means, now just say here, this operation we have, before that we need to commit it. We have one more thing called commit operation. This is commit operation. Okay, what is commit? See, this is the first step. Let me mark it. The first is clone. Okay, and second is commit. Third is push. Okay, but whereas in SVN we have checkout and then commit. Checkout and then commit. Okay, but why do we have push in Git? In Git have something we call extra call push. Okay, what is that push? Before that we'll look into what is commit, then we'll try to look into push. Anyway, we know what is push means, right? Pushing means just do the changes and add the changes to the central repository. That is push. Okay, we know that. Okay, whereas in SVN we call it commit, but commit in Git has a different meaning. So whenever you do the changes, right? So whenever you do the changes to the local repository, those changes should be committed. So what happens when we commit it? The commit changes will be whenever you commit it, the changes whatever you have done to the local repository will be saved to a local repository. Internally, Git maintains a local repository within every developer system. So whenever they clone the repository, whenever they clone the central repository, what happens? The repository will be cloned onto developer's machine. Then internally, a repository will be created, internal repository, which we can't see that. Okay. So what happens here? Whenever we commit it, those changes will be saved into your local repository. That is what we call commit operation. So you must commit the changes first, then push the changes. You must commit the changes, then push the changes first. Okay. So that's why first step is clone, second is save the changes, and then push it onto the central repository. Okay, clear? Right. But now I was talking about distributed architecture, right? Git works on distributed architecture. What does it mean is, what do you mean by distributed? So we'll have one central server and then attached to some sub servers like sub machines, distributed systems. That is simply distributed. Okay. The same concept works here. So look at here, we have some central server, central repository, and every developer will be having a distributed repository within their local. That is the reason you need to commit it first to the local repositories. Then you can commit them to the central. That's why we call it distributed architecture. Git works on distributed architecture. Okay. Now you understand why it is called distributed architecture. Okay. So, but what is the advantage? Why do we need to commit it? Why do Git has come up with this concept? It's very simple. For example, if you take SVN architecture, it works on purely client server architecture. Okay. What if, for example, if this server is disconnected? If the server is disconnected, can you push the changes? You can't push it. The server is down. How can you push it? Right. But here, even if the server is disconnected, in this case, still you can save the changes onto the local repositories. Then once the network is back, once you are connected to the network repository, then you can start pushing it. That is the advantage of distributed architecture. Okay, clear? So instead of pushing the changes every time, like even for small thing, then what we do first, we save them everything onto the local repository, then we'll push them everything at a stretch onto the central repository. That's why Git has come up with this concept, distributed architecture concept. Okay, Clear? So this is how the Git works. Okay. The only difference is here we have we have internal repository. So you need to change. You need to save the changes to the internal repository with the help of commit operation. So once you do that, push it. Okay. Now do not get confused between svn commit and then git commit. If you do git commit, the changes won't be applied onto the central repository. Okay, the changes will be applied onto the central repository within git only when you push it. Okay, if you commit it within git, those changes won't be applied onto the central repository. Okay, clear? So these are the major differences between svn and git. Okay, and apart from that, everything is same. Every architecture and everything. See, repository itself is every repository, as I said. See, that is the reason for svn I have taken almost like a full session for svn. Whenever starting the svn, right, just for repository concept itself I have taken the full session theory part, because the theory concept is same. It's same, every concept is same. The cloning, but the terminology difference here. Here it is called clone, okay, but here it's called checkout. But commit, push, that's it. Apart from that, everything is same. Okay, clear? Okay, now, so now let's look into the life cycle, git life cycle. Okay, so we already know this anyway, but anyway, let me. So first clone it. Okay, first clone, and then and do the changes. Okay, that means edit the repository, and then after that commit, correct, and then push, right. So clone it, edit it, commit it, and push it. Okay, clear? So we look into these steps again in a graphical manner. So first here we have the central repository. Okay, the first is clone operation. This is the first step. Okay, now who is cloning it? Obviously developers. Okay, this is their working copy. Okay, and then do the changes, add, edit, or whatever. Okay, and then after that modify working. That means if there is any, see what happens when you do changes, the working copy will be modified. Okay, right, and check for the status, git status, or whatever we have seen svn status, right, the same git status, and then review the changes. So what happens when you go for svn status? It shows the differences. Okay, so what are the files being added, what are the deleted, so it reviews the changes. After that, commit operation. Okay, now here we are committing it. Once committed, what is the next step? Push, right? Here is a push. Okay, but whenever you push it, look at here, I'm pushing here, right? I'm pushing it. Whenever you push it, if there are any conflicts, in SVN we have seen the conflicts, right? So what was the conflict? The parallel, if the users, if the two multiple users are accessing the same file, the conflicts, right? Whose changes has to be applied? Whether developer 1 changes or developer 2 changes to the central repository. We have seen the conflicts. The same conflicts. If there is any conflict, will it be pushed? Will it be committed in central in SVN? Was it committed? You seen that? No, it won't be committed. So before committed, you need to fix a conflicts. So that's why we have seen that. So before committing, we are fixing the change, we are fixing the conflicts. If there is any conflicts, then it won't be coming, it won't be, push will be failure. If there is any conflict, then obviously you need to fix the mistakes, fix the conflicts. Then you can start pushing it again. Then this time it will be success. Okay, if the first time it is a failure, then you need to fix it. After that you can start pushing it. Clear? So this is how the life cycle works. Everything is same except the terminology is different here. Except the terminology is different. And here we have one more thing, right? Update. What is update? Sorry? Conflict? Yeah. See, what do you mean by update? Firstly, like you almost right. Okay. The updating means if there the version within local and the central is different, so you can't push it, right? You can't push the changes. Then what we need to do? We need to sync the local repository. That means we need to sync the working copy as well as the central repository. We need to sync it. We need to sync the changes. Okay. How can we do that? With the help of update operation. Okay. See, every operation is same. Even the almost like the commands are also same. Okay. Clear? So it's not only Git. Like even if you go for some TFS, something, some repositories there, TFS I guess, right? Even if you go for other repository, every repository works on the same concept. Okay. So every repository is same concept. So that's why if you understand one repository, it's easily to understand the other repository. Except the terminologies might be different. The terminologies might be different. That's it. Okay. Clear? Any questions? It's very simple anyway. Okay. Let's look into the installation part. Okay. First, we'll look into the installation part of server on Linux. Okay. Right. Okay. Now, so if you look at the installation part, but before you install Git, we have some prerequisites. We have some prerequisites. You need to install some prerequisite packages. Okay. So what are those packages? The package is OpenSSL develop. So why I have mentioned star here? Yeah, all packages starting with, yeah, dependencies also should be installed. The dependency packages are all the packages starting with so and so OpenSSL devel should be installed. Okay, right. So here I'm going for yum install. What is yum install? So this is a yum is a repository in terms of RHL. I think we have seen this RHL. Okay. So with the help of yum command, you can install any packages. Okay. And here let's talk about this yum repositories. Yum repositories. Okay. See, in RHL, see yum is a repository, so you need to set up the repository manually. You need to set up the manual repository. But what does yum repository contains? What does yum repository contains? Yum repository contains all the packages. Look at here. We are installing this package, right? So what is the package name? OpenSSL devel. Okay. But where this package will be available? Within the yum repository. Within yum repository, the package will be available. So yum repository contains the packages. Yum repository contains the packages. Okay. Okay. But how to set up this yum repository? How to set up this yum repository? Well, I have a document. Okay, I'll be forwarding the document. You can go through you just follow the steps. It's very simple steps we have. So I've given clear steps. Okay, just follow these steps. I've given clearly what you need to do. Okay, so there are very about hardly barely 10 steps, not even 10 steps. Okay, just follow these steps same as. So whatever I mentioned within the document, just follow the steps. Okay, it's very simple one. If you don't get it, let me know. Okay, hardly the 10 steps, that's it. The commands, simple commands, just copy and mount it, that's it. Okay, and I will be forwarding this document once the class session is finished. Okay, right. And where were we? Right. But if you go for CentOS, if you go for CentOS, what is CentOS? So what is RHEL? RHEL is the flavor of Linux. You can call the flavor or else or provider. Is one of the provider of Linux. Okay, and CentOS is also one of the flavors. Okay, it's also one of the flavors. So, but if you go for CentOS, the advantage is no need, no need of installing yum repository. So here we are setting up in RHEL, right? In RHEL we are setting up yum repository manually. But if you go for CentOS operating system, there is no need to set up this yum repository. Okay, so that is the advantage we have. The yum repository comes by default. Okay, so that's why. So if you are from non-Linux background, go with CentOS. Try to work on CentOS. And RHEL and CentOS commands are 90% commands, they are same. Every command whatever works on CentOS, it also works on RHEL. Every command is same. Okay, clear? So go with M repository, go with CentOS, and for online, those who want CentOS, the URL is already available within the shared drive. I've shared already a drive. So in that drive you can find every application. Like if you want to download anything, I have uploaded and even I have shared it long ago itself. Okay, so to just check it properly. In that there is a document. So in that document you find a download link uh, to download the CentOS. Okay, but RHEL I have uploaded it. RHEL operating system itself is uploaded, the ISO file, so you can download it. But if you want to download CentOS, I have provided a download URL. You can go with the download URL. Okay, and for classroom, you can get your pen drives. I can copy that for you, no issues. Okay. Okay, right. And then there is one more package called curl-devil star, and then other is expected. And there is one more package which is group install development tools. So you need to also install this package also, but this is a group install. So what is this group install? So whatever all the packages within this package, every package within every package within this package will be installed. It is like a group install. Everything will be installed within this development tools. See, development tools is a kind of a package. Okay, within the package we'll be having some sub packages. Okay, when you go for group install development tools, all the sub packages within the development tools package will be installed. Okay, but what the development tools yeah, Sunil, we'll be working on even in the past. I mean, for Subversion and Jenkins, I was working on RHEL 6. Even now, we'll be working on RHEL 6. So if you want to download RHEL CentOS 6, you can also download it. Okay, right. So here, just download this group install. Sorry, install it. Group install. In this group install development tools package, we'll be having a C compiler. C compiler and related package to C compiler. But why do we need C compiler? Is the only reason is Git uses C compiler. Git uses C compiler, CC compiler. C compiler. Okay, so that's why we need the C compiler will be available within this development tools. Okay, so try to install this. Okay, clear? Right. And then installation is okay. So first download the tar file for Git. Okay, download tar file for Git and then extract that file. Okay, so let me show this process. Here it is. Okay. And then I have already an extracted one, so I want to remove that. What is missing, Sunil? So 1 second, let me check it. Can you share the Git tab file also? Can you share that? Yeah, sure. I will do it. Right now, so here we have the Git tab file. Okay, here we have Git tab file. So what do we do with the tab file? We need to extract it. So how do we extract it with the help of tar command? Tar hyphen x z vf and then the tar file name. Okay. Now here we have that Git file. It is extracted. Okay. Now, so once it is extracted, what you need to do is, okay, you just create a simple directory. Okay, just create a plain directory now. Create a plain directory. So once you create the plain directory, you go to some location. Okay, in some location, just create some mkdir and then some git1 directory, whatever the directory you want. Just create a plain directory. Okay, clear? Once you yes, we are. Okay, so once you create the directory, okay, so you can have a directory created like this. Okay, so it is a plain directory, right? And then after that, what you need to do is just go back to the directory again, which is extracted. We extracted this file, right? So go back to that directory. Okay, clear? Right. So then be in the directory and you need to execute a couple of commands. You need to execute a couple of commands. So what are those commands here is, so make prefix equals to slash git1 all and then make prefix slash git1 install. So what is git1? So this was a plain directory, right? We have created a plain directory. So now what I want to do is I want to install, see, we have just extracted the git tar file, that's it. But did we install it? No, we are not installed it. Now let's install it now. We just extracted that file. But into which directory I want to install? I want to install that into git1 directory. Okay. Just try to execute these two commands. That's it. And then, so what is our git home directory as of now? Git1. Okay, because we have installed git in that git1 directory. Clear? Right. So we are done with the installation part. But what we need to do next? We need to set the path settings. We need to set the path settings. Okay. So we have seen that anyway. But let's again look into this. So where do we set the paths? Where did we set the paths for like Java or user home directory. Okay, in user home directory, then which file? Dot bash underscore profile file. Okay, yeah. So we are dot bash underscore profile. Okay, clear? But here the one thing is that if you do settings in the bash underscore profile, okay, git does not work. Okay, so you need to set that in bash rc file. Okay, so vi dot bash rc. Okay, so how do we set it? So what is this? Sorry, simple one. Export path and then the location. Okay, fine. So set that in bash rc. Okay, and once you set that, that's it. That is, you can go for git version is version, or else you can go for echo dollar mm, what was that? 1 second. Okay, just go with the git version, that gives you no issues. Okay, so now we are done with the installation part on server. Okay, so we have installed git on server, but one thing here, we just install it, right? We just install it, but is a repository created? So do you remember? Now try to recollect the SVN steps. Okay, while installing the SVN repository, what happened? SVN, we have installed SVN, and same time even repository was created. But did we create that manually? No, SVN itself has created that repository. But here we need to install it. After installing it, create the repository manually. Okay, clear? Right. But before that, okay, yeah, we'll create it. I have an existing one. This one, just want to remove that. Right. So we don't have now. Just create a repository now. Not repository, some directory by using mkdir command. Mkdir command and then some name, the directory name. Enter and then cd change directory git repo. Okay, clear? But do we have any files and directories in that? No, right? So this is a plain directory. Okay, this is a plain directory as of now. I am going to initiate this directory as the git repository. I'm going to initiate this directory as git repository. So now I want to create, I have created a directory, and this directory will be initiated as the git repository. Okay, so command is git init hyphen bear. So what does it mean? I'm initiating a git repository which is a bare repository. Bare means an empty repository. I'm initiating an empty repository, git empty repository. Enter. Initializing empty git repository. Okay, if you type ls, now you see some files and directories. Now these are the git supporting files, repository supporting files. Now we have the repository available. Okay, So what is the repository name? Git repository name. What is the location? Is slash root location. Within the root location, I've created git repo. Clear? Fine. Now let's start with. We are done with the client side, right? Sorry, so we are done with the server side. Obviously, we need clients. Okay, so we'll have again two types of clients: the Windows client as well as the Linux client. We look into both the things. Okay, but clients will be executing some commands, right? Clients will be executing some git commands. They need to have git installed on their client systems as well. Okay, so how do we do that? First, we'll look into git client installation on Windows system. Okay, client installation on Windows system. So how do we install it? We have git bash. Now git server installation is done, and then now the client installation, that's on Windows. Okay, so on Windows you need to install git bash. Git bash. You install git bash. Okay, right. So this is git bash. Okay, you can download it. Okay, just download it, and once it is downloaded, just double click on it. That will be installed. It's a .exe file. Okay, it's an application. Okay, it's a .exe file that will be installed. Go with some default steps. Go with the default steps that will be installed. No issues. Okay, right. So once it is done, you can access git bash from here. So what is a git bash? So git bash is nothing but that is the client side. Git bash is the client version of the git. Okay, and here all the commands are same as the Linux commands. Every command is same as the Linux command, like present working directory, ls. Okay, all these commands are same commands, same as Linux commands. Okay, and then clear, everything is same. Okay, now, so as a developer, what I want to do is I want to clone the central repository onto my system. Okay, I'm a developer, I'm a client, and I want to clone the repository from central to local system. Okay, right. But before that, fine. So first I want to create some directory. Just create whatever the directory you want. Into this directory I want to clone the repository simply. Okay, into this directory I want to clone the repository. Okay, and then cd git client. Okay, now I'm in this particular directory. Every operations I will be performing from this directory. But what is the next step? What's the next step? We need to clone the repository, right? Command is git clone. Okay, and then any guess? You are checking out, right? Yeah. Now git clone and the path. Path means here the IP address and then location of the repository. The same thing. Git checkout, svn checkout, right? Svn checkout and then the path URL. The same way here. It is the IP address and then repository path. Everything is same. Okay. It won't be generated, Sunil. Okay. So we need to mention that it won't be generated. Okay, so what is the system IP address? It's 185, right? It is 185. Okay, now, and what is what is our repository location? Git repo, right? In root user, sorry, in root directory. So this is the directory, this is the location, /git repo. Okay, clear?
In Windows,
Sorry, if you want to install Windows, the same thing.
we are using bash in Windows also.
Yes.
So there we don't need to make directory or something.
So we are clients, right? Clients, what clients do? They clone the repository. They don't create the repository? They clone. They use the repositories, right? So they're cloning the central repository. Okay, git clone. So I want to log in as root user. Okay, and the IP address is 168.242 and then 185. This is the server IP address, central server, central repository IP address, and then colon slash and then git repo. Git repo, right? Look at here. It is git repo. Git repo. That's on server. I mention the same thing here. Slash git repo. Okay, clear? And then just enter cloning into so and so. So Arishu, you want to continue connecting? Yes. Now this is the password of the server system. Okay. I'm connecting as, look at here, I'm connecting as root user. Okay. So this is the root user password. So warning, you appear to have clone and empty repository. Okay. ls, what was the repository name? Git repo, right? Git repo. Okay. Git repo is created. cd git repo. Now what you see here? Master. Okay. ls-a. You see .git, right? In SVN we have same directory. What was the directory name? Invisible directory. Remember. So whenever you check out the SVN repository, so there will be a directory created. What was the directory name? Invisible directory. Remember? .svn directory. Right? .svn directory. So whenever you check out, a .svn directory will be created. What is the purpose of the .svn directory? What kind of configurations we have in the .svn directory? Sorry? Jazz. It's not Jazz actually. So .svn. Once let me show you that. I think you guys don't remember that. So that's why you need to practice every day. Yeah, I have repository luckily. Look at here. .svn, right? Okay. So whenever you check out a .svn directory will be created, and here these are the supporting files. That means, see, we are doing some cloning of, we are doing some commit operations and update operations, so and so, right? So whenever you do so and so operations, and that is client is connecting to the central repository. Why only that repository? Why only that server? Why not the other repository? Why not the other server? Understand? So you will be having all such kind of settings within this .svn directory. The configuration level settings, the repository configuration level settings. Okay. So even I said the same thing even while installing this SVN as well. But again, okay, here the same thing we have .git. So let me change directory to .git. Okay, ls If you go for, there is a file called config file. Okay, vi config file. Okay, you see this URL, right? What it says, that's a path. Which path? Yeah, remote server path. That means central repository path. So whenever you do any pushes, so it will be pushed onto this URL. Do you understand clearly? Okay, so this is the .git will be having such kind of configurations. Even .svn will be having such kind of configurations. But in .svn you can't see the changes in .svn. You can't see such kind of files. But here they have provided this kind of files to view and change it. Okay. Now, for example, if you want to change it, for example, I change it to some 190. Then what's going to happen? Sorry, connection refused. Yeah, that's correct. Connection will be refused. That's correct. But if I have the same server, if I have the server existing, and even on that server, if I have the repositories created, just say, then what happens? Those changes will be pushed onto central that server and that repository. Okay. Now you understand the purpose of this file. Okay. Let me check it. Yeah, it is not saved. Okay, no issues. Fine. Okay, clear? And let's try to have a client. So we have a client ready on Windows. Let's get ready with Linux client as well. Okay. Here I'm looking into two types of clients. Okay, one is Windows client, other one is Linux client. Okay. And how do we install Git on Linux client? The same steps, whatever you have followed for server. Okay, just follow the same steps. So we have installed so and so steps, right, on server installation. Okay, just follow the same steps, whatever you are done on server. Okay, just follow the same steps. So git client side installation on Windows, it is git bash. But whereas if you want that on git client side installation, follow the same steps as git server installation. Okay, clear? So this is the server, sorry, client. The client is 184, server is 185. Okay. So let me check whether it is installed or not. Yeah, it is installed, no issues. Okay. And I want to remove that. See, there is no naming convention for directories. Okay. Okay. So now we need to clone the central repository, okay, which is on 185 server. Okay. Create some directory, some git client. Okay, and then cd git client. Okay, I'm in this particular directory. So what is the next operation? Git clone, right? Git clone, and then IP address, right? And then 185, right? Okay. Slash git repo. Okay. Try to clone it. Yes. Password. Okay. Checking connectivity. You appear to have cloned an empty repository. Clear? Now the repository is ready. Cd git repo ls-a. Here when we have git dot git directory. Okay, ls and then vi the config file. So vi config. Okay, check out the URL here. It is 185 242.185 and then slash git repo. Okay, the same URL, the same repository, central repository. Okay, so what does it mean? We have two clients. Okay, there are two clients. So one is Windows client, other one is Linux client. Okay, we have these two clients. Okay, right. And now let's start creating some files. Let's try from the developer's perspective. So I have to developer on Windows machine and then developer on Linux machine. I have two developers. Okay, first start creating some files as a Windows user, Windows developer. Okay, now, but before that, remember always you need to be in the working copy, right? The same concept. Okay, cd git repo. Now I'm in the master. Master means that is your working copy. You are in the repository. What is the repository name? Git repo. So always you need to run the commands from the working copy, from the master. Right. Now let's try to create some file. Some vi first we'll go with touch command. So as I said, every command same as Linux. Touch and some file dot java. Okay, clear? So ls the file is created. Okay. Now check for git status. So what is this master on branch? So we'll talk about the branches maybe after a couple of classes. Okay, right. So untracked files. What do you mean by untracked files? The file is not tracked by the git repository. That means file is not identified by the git repository. Do you remember in SVN, once you create the files, you need to add those files to the local repository. The same concept works here. Everything is same. That's why I said every concept is same. So now you go with there we are doing SVN add, but here git add, same thing. Git add and then the file name. So this is the advantage with Git. It gives a clear help. Okay, what you need to do next if you go for SVN's Git status. Okay. So the file.java is been added. So it's been created, not added. So we need to add that file. The command is git add file name. Okay, enter. So check for status again. The file is changes to be committed is so and so. So we need to commit the changes. We need to commit these changes. But here it says that the file is okay, so file has been added, right? Now file has been added, but is it committed yet? It's not committed, right? See, what do you mean by commit? So we need to commit that to the local repository. Now the file is added. We need to add that file to the repository. Okay. So what do we call this stage? The stage from once you add it and before you commit. Okay. Now here we are just added, right? Git add. But are we committed? No, we are not yet committed. So this yet to commit. Yet to commit. So what do we call this stage? This is, we call it the staging area. So after you add and before you commit, there will be some status. We call that staging area. Okay, clear? So this is here, the working copy. Here is the working copy. Here is the repository. So git add and then git commit. So that means after commit and then before, sorry, after add, before commit. We call it staging area. Okay, clear? Now, so that's what it says. If you want to unstage this file, if you want to unstage this file, you can go with git remove and the file name. Now we know what is staging, but if you want to unstage it, if you want to unstage that file, you can unstage it. See, there are in cases like SVN. So once you git add, the file will be added to the working copy, SVN working copy. But if you want that has to be uh, deleted from SVN, like see that is a SVN file as of now. That is SVN file. But if you want to delete that file, what do we need to do? We go with SVN delete, SVN remove. Then what happens if you go for SVN remove? The file itself will be deleted physically, even from on your machine as well. But I don't want to do that. Instead, what I want to do is, like SVN, I want to go for unstage it. I don't want SVN to commit that file to the central repository, but I want to maintain that file physically. Such kind of feature is not available within SVN, but we have that feature available within Git with the help of unstage. Sorry? Yes. Yes. So the file won't be added to the central repository, even to the local repository. But we don't have such kind of concepts within SVN. We have them in Git. Okay. If you unstage it, for example, let me go with git remove file.java. Okay. Is the file is deleted? The file is not deleted. That is unstaged from Git repository. Now Git does not understand this file, but such kind of feature we don't have in SVN. Okay. For example, git add file.java. Instead, for example, I have one more file called file2.java. By mistake, if I go for file2.java, then what happens? The file will be added. But if you want to unstage it, do you have such kind of feature in SVN? We don't have it. You need to delete that file. So that is a big disadvantage. But here we have the advantage. Okay, now you can stage it again. It is added. The file won't be deleted physically. The file will be deleted, okay, from SVN repository logically. Okay, git status. Now it is commit. It is added now. It is staged. That is the advantage of staging area within Git. Okay, right. Now Git. What is the next step? We have added, right? What is the next step? Commit. Yeah, correct. So git commit -m comment. Okay, the same. Adding file dot Java. Enter. So it has been added. Look at here, it has been added. So every time you see, okay, like it has been committed, adding files, so and so, you can see everything. One file is changed, and zero insertions, zero deletions. So what are those insertions? We'll talk about the insertions anyway. Okay. Now file is added, right? You can check for git status again. Okay. See, every time you see master, right? Master, master. So what is that master? See, master as of now, try to understand it is a branch. So what is a branch? In SVN, we have seen branches, right? We are creating some branches. The same thing here, even in Git, we'll be having the branches. Obviously, we need to create the branches. By default, a branch comes by default, the master branch. It comes by default. Okay. And whenever you push it, you need to push it to the master repository. Master branch. That is by default. But if you want to push it to a different branch, you can also do that. But as of now, for today and tomorrow, we'll push it to the master, and after that, we'll push on to the our customized branches. Okay, clear? So what is the next step? Push, right? Git push. Okay. Then you need to also mention origin master. So what is master? As I said, there's a default branch. Okay, so the file will be added to the master branch, but if you want, that has to be added to some release one branch. Okay, you can also do that, but before that, you need to create that branch within the local first. Okay, so anyway, we'll talk about them later on. As of now, I'm pushing on to the master. Git push origin. Origin means the branch and the branch name. Okay, and then with this, what is this? Root 123. It's done. Okay, so it is success. It is created to. It's been pushed onto the master branch. Okay, clear? Now, so how do we know whether it's been pushed or not? How do we know? For example, just say this is I'm on server. This is on central server. I'm on central server. So what is our repository? Central repository. This is the central repository, right? Okay, we have something called branches. CD branches. Do you see anything here? All right. Okay. So now, but if you go to references, CD reference. So there is master created. Okay, master is created in references. Okay, that is created in reference heads. Why it is created in references heads means because that is the default one. If you create any manual branches, you can see them within the branches. Okay, or else do not get confused. Now, so we have created master, right? The master is created now. But is it a file or a directory? It's a file, right? But can we open that file? You can open that file, but you can't see anything, right? So, but I want to view the data. I want to view the data on the repository. So, how can we view the data in SVN? In SVN, right? So, we are trying to view the data within the repository. How we are doing it? Through the yeah, server. But on server we don't see the data, right? On server we don't see the data. Then how can we see the data on the repository? Yeah, that's correct. So that means we are using a browser, right? Do you remember? So we install Apache server, Apache service. Okay, we are installing Apache service, and then integrating Apache service with the repository. Then we are looking into the data through the browser. But here we don't have such kind of concepts. So what you need to do, you can clone the repository. You can clone one more repository. Just say, so here I have one more repository, right? We have created one more client repository. We have cloned one more client repository on Linux client, correct? Now he wants to have the files on. He wants to clone the files from central repository to his local system. Okay, and what is the command? Sorry, git clone. So we already cloned it, right? We already cloned the repository. Now we are in the master. So what is my requirement? I have some files on central repository. I want to get those files onto local repository, but the repository is already cloned. Then what we need to do? Sorry, couldn't get it. Sorry, change. Changes. What do you mean by changes? Yeah, we already cloned it. Then we now see developer one has already done some changes to the central repository. Now as a developer two, I want to have his files on my repository. Correct. Okay. That is go for update. Okay. So now I want to go for SVN update. Okay. Did we clone it? No, right? We did, right? We did or not? We did, right? We did clone it. Okay. Then git update. Oh, it's not update. What is that command? Git pull. Sorry. It's git update is that's in SVN, right? So it is the command is git pull. Okay. So whenever you go for git pull, then the repository will be updated. Okay. So it is git pull. Now, so what do you see here? It has been updated, right? Now we have file1.java, right? The file1.java has been added. Now developer 2 is also able to access the files. Who has created this file1.java? Windows user, right? Now a Linux user also able to access this. Okay, clear? Right. So yeah, so that's all for today, and let me give you a quick review of today's session. Okay. So what we have done today? So we have created repositories. We have initialized repo. We are done with installation part. Installation part. Okay, and then okay, then what else we have done? So installation part, and then from client side. Okay, from client. Okay, so from client side. Okay, so we were cloning the repositories. Okay, and then as well as changes, and then commit them. Commit these changes. Okay, we are done from both clients, from Windows client as well as Linux client. Okay, and in tomorrow's session We'll look into the how to resolve the conflicts. How to resolve the conflicts. We'll look into this. Come on. Okay. What is a conflict? We have seen what is a conflict anyway, but anyway, we'll look into the conflicts. What is a conflict? How to resolve the conflicts. Okay. Thank you, guys.